Welcome back, everyone, to the eCoreAcademy e-learning platform. Today, my name is AJay back with another geometry video for you all. Today's lesson topic is all about quadrilaterals and their properties, and we're going to be looking at different types of quadrilaterals that we haven't necessarily gone into specifics with. We're going to be looking more towards kites and trapezoids today, two different classes of quadrilaterals, as we've already looked at different types of parallelograms. I'm going to be saving parallelograms for later, the specific type of parallelograms, as we've already gone through rectangles, triangles, squares, the whole 9 yards with rhombuses as well. So we've gone through all of those four major types of parallelograms, and they're also types of quadrilaterals. So we're going to be shifting our focus into these abnormal quadrilaterals that we haven't necessarily gone into depth with. I haven't mentioned them before, but I do want to give an entire new introduction to this, introduce new parts of these figures, new identification processes, and of course, make you a bit more acquainted with some of the problems you'll be coming across. And at the end, I'll be doing a giant quadrilateral tree diagram that I'll be drawing out. So I do recommend that you draw it out yourself as well. It's very important, and it can help with a lot of geometric classification problems. Very organized and very simple in tail. So before we jump into today's lesson, please make sure to smash that subscribe button down below, hit that like button on this video, as well as hitting that post notification bell to get notified on any of our channel's latest posts, located right underneath the subscribe button. Once you've done that, let's get right into today's video. So the theme and purpose of this video here, quadrilaterals and their properties, is just to take a closer look at specified properties and specific classifications of kites and trapezoids, which are two different types of quadrilaterals. We're going to be looking at kites and trapezoids, and then we're going to be relating them to different types of quadrilaterals, the different classes, and then we're going to be showing you the diagram, the quadrilateral tree that goes in order of specific, generic quadrilaterals, all the way to your most specific quadrilaterals as well. So it's going to be going in that descending order. So let's get right into it. So let's look at kites and trapezoids to start this off. Let's look at an overview of what kites and trapezoids are, and let's take a closer look exactly on what they actually supersede as their own figures and how they actually differ from other types of quadrilateral classes. So a trapezoid, I'm sure you're all familiar with this. If you've watched my previous videos, I have, shown some light on trapezoids, but not yet kites. But you should be fairly familiar with trapezoids already coming into geometry. But trapezoids are a quadrilateral, meaning a closed figure. It's a type of a quadrilateral is a type of polygon with 4 sides, and it's a closed figure. And a quadrilateral is a form of a polygon, a form of a figure with exactly 4 sides given. And it's one of the more generic quadrilateral classes. And a quadrilateral, it's a quadrilateral with exactly 1 pair of parallel sides. Now we know that parallel sides are sides that have the same exact slope, and they basically never intersect for their entire the entirety of their length. So a trapezoid, it's a type of quadrilateral that has exactly 1 pair of parallel sides. So that's our definition for trapezoid. Fairly simple. And then, of course, a kite. If you think about a kite in general, a kite is what you're going to actually be attaching to a rod and flying up in the sky using the wind as your own propellant. So that's exactly what a kite is in terms of geometry. The geometric shape of a kite represents the actual realistic figure that you actually fly in the air. So a kite is a quadrilateral with 2 pairs of congruent adjacent sides. So all that's saying is you have 2 pairs of congruent sides, and those sides must share a common point. So those sides are going to be sharing a common point, and of course those pairs will not be interrelated in any manner, meaning they won't have any congruency amongst each other. Those pairs will be considered separate. So let's look at our examples here. So this is a trapezoid here, as you can tell. It's not an isosceles trapezoid. I'll get into what an isosceles trapezoid is, but it's a regular trapezoid in general. So it's a trapezoid. It has 2 pairs of parallel sides, and then, of course, it has different relative side lengths and angle classifications, which I will get to later on in this video. As you can see here, judging by the definition of a trapezoid, without going into too many specifics, we can see that it's classified by 1 pair of parallel sides, and as you can tell, these 2 sides are going to be parallel. And I have mentioned before, the bases and legs of a trapezoid, but yes, these two sides will be parallel sides. And of course, your parallel sides of trapezoids are going to be bases, so I'll mention that later as well. And then finally, of course, you have your kite here. I'll write this out. So your kite. And if you look at it, it looks just like the kite that you're attaching to a string, attaching to a string and you're flying it out attached by a string to a little rod in your hand. Say, for example, let's assume that this is your rod. So it's attached to a little rod and you're holding onto it, letting it fly in the air. That's what a kite is. And of course, by the generic definition of a kite in geometry, it's a quadrilateral, 4 sides, and a closed figure. It's a polygon with 2 pairs of congruent adjacent sides. And just to give you a little recap, congruent means equivalent sides, equivalent in length, measure of length. So adjacent sides are any sides that share a common point together, basically the sides that form their own angles. And there's only 2 pairs of those. So the pairs will be these bottom pairs, these bottom legs. And as you can see, it's quite obvious which pairs are most likely going to be congruent in this kite shown here. But these sides are adjacent, so I'll mark these off with 1 valued tick mark. So these sides are going to be adjacent and congruent. And then these sides are going to be adjacent and congruent. The double tick marks are going to be congruent and adjacent. And they both form their angles here. And I'll show you the common properties that both of these angles will have later in this lesson as well. So now let's move on to a more specific look and outlook on trapezoids. So let's get into the specifics of what trapezoids are, and I'll show you a bit of algebraic examples representing these formulas and some of these problems with algebra. So trapezoids part 1. Let's look at the properties of trapezoids. Very simple. So trapezoids have 2 legs and 2 bases. Bases are parallel. So if you're shown a trapezoid, you're going to have 4 sides, of course, and you're going to have 2 legs and 2 bases. Both of them are interrelated. They're not interrelated, but they're related with each other. So you have 2 bases, and the bases are the parallel sides of the trapezoid. Most likely are going to be what's on the bottom and what are on the top, and that's actually what's used to calculate the area of a trapezoid. If you recall, the area formula for a trapezoid is area equals the average of the bases multiplied by the height given extensively. So trapezoids have 2 legs and 2 bases, parallel bases as well. So in the standard diagram, A, B, C, D, so that's A, B, C, D. I'll write this out here if you can't see that. Trapezoid A, B, C, D. The base angle pairs. So like I said, if you look at a triangle, the base angles are basically your angles in relation to your base. And if you look here, you know that BC and AD are going to be the bases because they're directly opposite from each other, and they're both obviously the parallel sides, top and bottom. So BC and AD are the parallel sides. And if you're looking at the standard diagram, the base angle pairs are going to be BC. So I'll write this out here. BC, angle B, and angle C are going to be, sorry, not the congruence. So these are both going to be one set. So set one of base angle pairs because they're directly on the base. So these guys are the 1 angle pairs here. And then A and D, angles A and D, are going to be set 2 of base angle pairs. They're just angles that are located in relation to the base. So since you have 2 bases, it's going to count for all angles and relationships. You just need to be able to differ the angle pairs, what pairs are actually given in. And if you look here, you can tell that these 2 are going to be the legs. So these guys are going to be legs of the trapezoid right here. And as I said, this is base 1 on the bottom, base number 1. And then over here, BC is base number 2. And just a quick formula here, if you don't already recall, the area for a trapezoid, I've already mentioned this in my previous video, but it's base 1 plus base 2 over, base 1 plus base 2 over 2. You're trying to calculate the average. Base 1 over base 2, in parentheses, multiplied by the height. And of course, your base 1 and base 2, that's your first base and your second base. You're just adding them together. So the lengths of BC and AD, in this case, you'd be adding them together. And then you'd be dividing them by 2 in order to find the averages of the bases. And finally, you'd be multiplying it by the height. And the height would look something like this. It would extend from one vertex at the shorter top base as it intersects the bottom base at a 90-degree angle, and that would be your height. It would be given separately as it's not always included in every type of trapezoid. It's only included in right trapezoids, which are not very commonly come across, and you're not always going to be given that freeway, almost like a freeway ticket to calculating your area. So let's move on to trapezoids part 2, and we're going to go further properties of trapezoids. We're going to further examine these properties. So in trapezoids, same side interior angles are supplementary but not consecutive angles. So if you recall to my previous video on parallel lines and transversals, I talked about same side interior angles. And same side interior angles, the theorem basically infers that if you have two same side interior angles, they must be supplementary, meaning they add to 180 degrees. Two angles that are on the same side of the interior of an intersecting line to two other lines that are parallel, they must be supplementary, which means two angles that add to 180 degrees. So it's saying same side interior angles are supplementary, but not consecutive angles, and I'll show you what that is with the diagram. And then, let's look at this diagram first of all. So if we're looking at this diagram, what I'm trying to say is same side interior angles are supplementary, but not consecutive angles. So all that's saying is if you have two angles that are on the same side interior of an intersecting line, that means they're both going to be congruent. As you can see here, these base angles are obviously going to be congruent, but consecutive angles are not always going to be congruent. However, that's the main differential. So before we move on to the next slide, I just made a quick correction here on my diagrams, just so that none of you guys get confused with this concept. But if you're looking at what I said here with supplementary angles with the same side interior angles, the same side interior angles are going to be these angles here, these angle pairs. So I'll mark it with the double angle here. These angles are going to be supplementary, and these angles are going to be supplementary as well. They add to 180 degrees. And the reason being is if you have two parallel lines, this leg here will act as a transversal. Therefore, these guys are going to be the same side interior angles of each other, and both sides will add to 180 degrees. Their angles will sum to 180 degrees. And then, of course, I've given you a specific type of trapezoid. It's an isosceles trapezoid. So an isosceles trapezoid has congruent legs. This is an isosceles trapezoid shown here. So it has congruent legs, as shown here by the three marks here. So it has congruent legs, and it also has congruent base angle pairs. So these angles in turn, these angles would be equivalent. These angles would be congruent, and these angles would be congruent because this is a isosceles trapezoid. And also, the diagonals of a trapezoid, isosceles trapezoid, would be congruent. So this line here and this line here would both be congruent, indicated by the double tick mark. So these two lines would be congruent. And all a diagonal is that it connects. So a diagonal connects opposite vertices. So it's a line that connects opposite vertices, and you're going to have two diagonals in a trapezoid, and both diagonals, in this case, in an isosceles trapezoid, will always be congruent. Now let's move on to trapezoids part 3, and let's look at the midsegment of a trapezoid. I'm going to be doing the midsegment of a triangle in my next video as well, so I'll be going in depth with that if you get a little bit confused with this. And I'll be doing some more trapezoid and kite problems in that video as well, since it's a bit of a short lesson. I wanted to combine all of these together and put concepts that are alike together. So let's look at the midsegment of a trapezoid. The midsegment of a trapezoid is a line segment that contains the midpoints of the legs parallel to the bases. So a line segment, if you know what a midsegment is basically it's basically a line in the center of a figure that is halfway from it's basically midway between both the top vertex and the bottom. Both the top and the bottom, it's halfway through, and it connects the sides perfectly, does not intersect the sides, stays within the figure. And it's the line segment that contains the midpoints of the legs. So if you take the two legs of the trapezoids, think about an isosceles trapezoid where they're congruent, and you're going to basically find the midpoint of those with the midpoint formula if it's on a coordinate plane, or with the length formula and putting an actual point there, and then you're going to just connect that line there, and it'll be halfway from both bases. It'll be equivalent distance from base 1 and base 2. So the mid-segment formula is going to be base 1 plus base 2 over 2, because like I said, it's going to be the equivalent distance between both bases. So it's going to be the distance between both bases, or the value of both bases, over 2 in order to find the length of the actual mid-segment. It's going to be it's going to be the average of the value of the bases. And the mid-segment of a trapezoid is actually what's used in the formula, the area formula for a trapezoid. Because if you think about it, we're doing base 1 plus base 2 over 2 times the height. You're trying to find the average of the bases, the average length of the trapezoid, and multiplied by the height. It's very interesting here. So I'll just say here, used in area formula. And then this is our diagram, of course, with our mid-segment in the very center. And these 2 points here, its endpoints of this very mid-segment, will be the midpoints of the legs of this trapezoid. Also, you will see here these congruent tick marks when you split a line by its midpoint, partition it by its midpoint. Its two halves will both be equivalent to each other, as shown here, and that'll be equal distance from both sides. So it'll be equal distance from both sides. And also, another type of trapezoid that I wanted to show you and talk to you about is a right trapezoid. I'll be using that in a later lesson, but it's considered a type of trapezoid due to the fact that it does follow the fact that it needs one pair of parallel sides, and exactly one pair of parallel sides, but it's actually what forms a right angle here. So I'll show you what that trapezoid will look like. So it looks something like this. It has a right angle here, as shown, and it does not have congruent legs, but it's what's used to basically calculate the area of a trapezoid. Very smooth calculation. So that's the other type of trapezoids. You have isosceles and right trapezoids. And then finally, let's look at kites. Let's look at some kite properties. Kites aren't very common to be used in geometry. Many courses don't even include kites in their course, but I just wanted you guys to get a bit more familiar with kites. I won't be going in extensively with kites as very much, but of course I will get you acquainted with them. So the properties of kites. And a lot of times people get kites confused with rhombuses. Well, kites are their own type of quadrilaterals, but rhombuses are a type of parallelogram, so that's something completely different. So properties of kites. A kite has exactly one pair of opposite angles that are congruent. So it has one pair of opposite angles that are congruent. The other pair are non-congruent, and they're not interrelated. These two pairs of angles will not be interrelated. And then the diagonals are also perpendicular. Like I said, it's a diagonal of any figure is what connects opposite vertices of that very figure. So in the fact that it's a kite, you're just going to be connecting the two lines that are basically directly across from each other, the 2 points that are directly across from each other, in order to form the diagonals of your kite. And it's what that does is it actually intersects at a 90-degree angle due to the fact that it's a perfect horizontal and vertical line. And when you're doing that, you're actually going to split the figure into four different triangles, which actually helps you to calculate the area of the kite. There's no given formula for area of a kite. All you need to do is draw the diagonals and make 4 different triangles with 2 pairs of congruent triangles to calculate the area. So I'll draw this out for you. If you're looking at a kite like this, with our little points here, vertices here. And if you're looking here, what I'm trying to say is these 2 angles that are directly across from each other, these will be the given congruent angles. It has to be given here, so these could be the congruent angles or these could be the congruent angles. But if these 2 are the congruent angles in the figure, that means these angles must be of different lengths. Different measures. So these will be of completely different measures. And that's how I'm trying to signify that. But aside from the angles that are congruent, I want to show you what the diagonals will do and form different triangles. So if you're going to form your diagonals, you're just going to draw your lines across and connect opposite vertices together. Sorry about that. Connect these opposite vertices together as shown here. And when you do that, you're actually forming a 90-degree angle here. And after you do that, you can see that you have a 1, 2, 3, and 4 triangles formed. And all you need is the side lengths of course, your kite given in order to calculate the area of it. And of course, these two triangles here will be congruent to each other, and these two triangles here will also be congruent to each other. So that's how you calculate the area. Sum of 1, 2, 3, and 4. The 4 different triangles. Finally, I'm going to, like I promised you at the beginning of the video, I'm going to be showing you quadrilateral relationships through a quadrilateral diagram. I'm going to be drawing it out with you, so I encourage you to please draw this out with me, or pause this when I'm done and take a picture of it. It's very important. You're going to be utilizing this throughout the entirety of this geometry course, whether you're taking this, with us at eCoreAcademy, or if you're doing it at school. I'm sure it's going to come in handy. So let's draw out this quadrilateral diagram. So we know that quadrilaterals start as polygons. So we know that polygon is a closed figure with straight edges and points. So we know that it's a polygon. So let's draw quadrilateral up here, and it's a specific type of polygon. That's where it branches from. Quadrilateral. And then now we're going to go into a bit more specific. We're going to label the different types of quadrilaterals. So the first type that we know is, of course, your parallelograms. So I'll write here parallelogram. Your other type of quadrilateral is your trapezoid. And your third type of quadrilateral is your kite. And then if you're looking at your specifically given parallelograms, you have, of course, your rectangles. And your rhombuses. And then finally, you can tell that a rectangle is a specific type of square as well as a rhombus. So rhombus, a square is a special type of rhombus, and rectangle. So it's a square here. Square. And then finally, you can look at your trapezoids. A specific type of trapezoid is, of course, your isosceles. And of course, there are no specific classifications of kites. And I just want to put isosceles out there for now for trapezoids. But there, of course, are specific types of trapezoids, like right trapezoids as well. So I can also include this here, right as well, right trapezoid. Right there. So that's your right trapezoid as well. And the kite does not have any further classification. It's its own special irregular figure. All right, everyone. So that'll be it for today's video. I hope you all enjoyed. This has been the eCoreAcademy e-learning platform signing out. Please make sure to like and subscribe down below, and turn on post notifications by clicking that bell icon right underneath that subscribe button. Also, please make sure to visit our website at www.ecoreacademy.org. It's down. The link is also in our description box below. We have full unlocked access to what we actually offer as an educational platform online. We have, of course, our integrated note sheets and worksheets that go along, as well as quizzes that go along with each and every one of our videos, organized into lessons under categories of all of our courses and our subjects provided on our website. We also have different tips and tricks, other perks that are also given additionally at our website, and of course, special events as well. All you need to do is make an account for free there, and you get full unlocked access to everything we have there. Of course, you can email us at eCoreAcademy@gmail.com. Our contact information is also acquired at our website. We have full unlocked access there for all of our contact information if you want to go a step ahead. But our website is our email is always open. Finally, please make sure to visit all of our socials in the description box below at Facebook, Twitter, and Instagram. We have our links down there as well, the full link access. We check out what kind of content we have there. Use our mediums to share it to anyone else who might need help with these given topics or might find any of our videos interesting. Once again, everyone, I hope you all enjoyed. This has been AJay Raj, and I will see you guys in the next one. Peace.